Hello and welcome to episode 20 of the ChessTDD series. And I actually recorded this a couple of days ago and had a lot of fun doing this particular piece of coding because I decided I've had enough of this class that's a little bit too busy. I'm just going to go ahead and figure out a way to refactor it. And it actually turned out pretty well. I was sort of fortunate in that I hadn't looked at this code in a couple of weeks, so that seems to turn out to be kind of good for refactoring, because then I look at this code like it's somebody else that wrote it and I get all critical and figure out ways to do things to it. So what I'm doing here actually to get started is you're kind of seeing me poke around a little bit and think. And what I'm thinking about is I had looked at the methods in that board class that were something like, I forget the name of them now that I'm not looking at them. Is this a vertical path? Is this a horizontal path? And what they were doing was that they were methods that didn't refer to anything, any kind of instance variable of board. They took as parameters board coordinates and they compared things about the board coordinates to one another. In essence, I'm going to take as an argument two board coordinates and I'm going to do things with the board coordinates only. That's actually a code smell that goes by the name of feature envy. You see what I'm doing here? Origin.x equals destination.x. That has nothing to do with board, so that begs the question, why is that in this class? And like I said, that's a code smell called feature envy, indicating that this is really probably a method that belongs in board coordinate, and one wonders why it's in this board class. I mean, I know why it's here because I did it as part of an extract method, but so I'm going to go and while everything's green, I'm going to refactor and everything stays green. So moving this method over to the board coordinate class isn't breaking anything. So I'm going to go do the same thing with horizontal. So this makes a lot more sense. It's kind of semantically nicer. I have a board coordinate object and then I ask the question, is this on the same horizontal path? And I pass it another board coordinate. And just like that, we've gotten rid of two methods on this board class, which is nice. And I'm not going to stop there. I went on to get rid of a whole lot of this, this concept of path. And I think, so what I'm doing here now too, I hadn't really, I don't think I've shown this at all during the course of recording this series, but one thing that's sort of hidden, and I just decided to do it now at a good stopping point, is that I do a lot of commits typically when I'm writing code. And it's something in some of the coaching work I'm doing right now that I'm trying to emphasize too with people, which is commit sort of often. And if I were working with other people, I'd be pulling code as often as possible, you know, depending on the particulars of the source control scheme that I was using. But this is, you don't need all kinds of fancy build machines and whatnot to do continuous integration. The basic core idea of it is that you want to sort of have a good master branch and get problems out of the way early. Everybody should be trying to, as much as possible, use the same bits. So that's just kind of a message as an aside. If you were watching me code on an actual project, you would find that I'm sort of making sure I have the latest code all the time, and I'm trying to commit code as often as I can. Doing no harm, committing code when it's, you know, compiling and tests are passing and everything. So what I'm doing here is I'm going to start a further bit of refactoring. And for the sake of ease, because of what I'm doing, I'm just going to inline declare this class so I can sort of reason about it all in one place. There's no sense going back and forth and confusing myself. So I have this idea that I'm going to do something called path checker. Basically, I think that the functionality I'm going to start to pull out of this board class is oriented around checking the path that I'm given. So I'll call it path checker and maybe revisit that name later if I think it needs it. So the first thing I'm going to do in looking at these methods that I want to replace is I noticed that you see a common theme is just about all of them take a couple of board coordinates, origin and destination as their parameters. So what I'm going to do is instead of having those passed everywhere, I'm going to make this a class that takes origin and destination as parameters to the constructor, and then they're going to be immutable arguments that get passed in. So for the existence of path checker, it's going to have an origin and it's going to have a destination. And then I can ask this path checker class some questions like, is diagonal path blocked? But there's one catch here. When I was refactoring this, if you look at these methods and if you're following along with the code, they're all instance methods, and the reason for that is because they're all calling this does piece exist at method. Everything else about them, they could be static and they could belong somewhere else. But the one catch is they all need to do this does piece exist at, and that's kind of a wrinkle here and maybe what's comes to be a little bit of advanced placement refactoring, so to speak. So what I'm doing is I'm saying, okay, this does piece exist at is happening at the end of each of these methods. And what we're doing is iterating through a enumerated sequence of board coordinates and then repeatedly calling does piece exist at on each of them. So what if instead of doing everything in these methods, we just got right up to that point where we have that enumeration of coordinates? And that's what I'm doing here. So I am sort of copying. I can't do a straight extract and just take this method and slap it on the new class because I'm not doing quite the same thing. What I'm doing instead is taking the first several lines of it and returning what it returns to get to the point. And you'll see a better illustration here in a second of what I'm doing. So now, having defined this method that's 75, 80% the same as this is horizontal path blocked, I'm going to instantiate one of these checkers, and I'm going to pass the constructor my origin and destination. And then once I've got that, I'm going to ask the checker for the points on the path. And I'm going to assume that it's a horizontal path. And what I'll sort of leave as a to-do list, I think I put it on at the end, is that once this class is fleshed out, you'll notice that I'm not going to be writing any new tests that cover this class right at the moment. So board is using this checker, and I might be inclined to write, and I eventually will be inclined to write tests against checker, but the tests that are covering board for the time being are perfectly adequate. So what I'm going to do here is call the checker to get the spaces. And the reason I mentioned the tests against this other class is I'm assuming a lot of happy path stuff here. So at the point at which I separate these two classes, suddenly you have a seam, and things I could kind of assume and control in this class internally, now that there's this public path checker class. So right now I was doing these checks to say, hey, is this a horizontal path? And then, oh, if it is a horizontal path, get horizontal spaces. Well, I can't assume that anymore. It's not in my control because it's two public classes. Somebody could pass it to spaces on the board that have nothing to do with each other. And then you have to start reasoning about, oh, okay, what happens if I pass it two things at the opposite corners of the board? And then I say, get horizontal path. Do I throw an exception? Do I return an empty enumeration? So that's all stuff for another episode. Right now, I'm just going through and I am doing my very best to remove code from this class. And specifically, I'm looking to remove all of the code that doesn't have anything to do with board or its operations. I'd like board just to be sort of oriented around that instance variable that's the two-dimensional array. I don't want to be doing all this figuring out of paths in this class. I want to delegate that elsewhere. And at first, I'm just inlining the instantiation of this path checker. But later, when you do refactorings like this, if you really kind of wanted to get more flexible, you could invert this dependency in a sense, I should say inject the dependency, and have board, optionally take via setter or constructor a path checker. And then you could inject different path checking schemes, I suppose. I have, over the years, gravitated towards doing that after a refactoring only when there's actually a reason, like when I actually, for some reason, want a second kind of path checker, so no sense speculating about flexibility. So this is all kind of more or less a repeat of what I just did. It's not especially different than what I was doing before. So this time I'm a little more confident. I see that I'm green, so the same pattern is applying, and that's good. So the next thing here to look at is this direct diagonal path method. This is going to be a little bit more complicated because it has this auxiliary method that it calls into, and the diagonal algorithm in general is a little more complicated. So the first thing I did is I got rid of the auxiliary method. If we want to make one such method in the new class, that's great, but it's going to be a lot easier to move one method over than two. And something I'll mention just kind of quickly as we look at what's going on here. Absolutely go out of your way, if you're serious about doing a lot of refactoring in code, to get yourself an IDE that allows a lot of automated refactorings. It prevents errors and makes your life a lot easier. I fully endorse. I mean, it's great to be able to use a minimal IDE and really reason about the code, but for refactoring like this, it to me is just invaluable. I'm not pasting things in and doing things and worrying that I've messed up the refactoring. So seeing that inline method be just so easy reminded me of that. So what I'm doing here is I'm going back and I'm changing what had been parameters to a method to class level fields that I'm referring to. And I'm probably just going to want to go in and, yeah, I see that I'm not compiling. Good to notice that. And I'm going to say return this instead of setting some useless local variable. And there go my dots again, so I know it's compiling. They're black because I don't have coverage there. So what I'm going to do now is instantiate a path checker again in this method and follow the same pattern. And I'll return the checker. I'm going to get its diagonal spaces, and then I'll return whether or not there's any space for which a piece exists along this diagonal path that it's found for me. I expect that to go green, and since it does, I can delete the rest of this stuff in here. And now this method is looking a lot simpler, which pleases me. And in general, the class is getting shorter in terms of lines. And what I'd really like to do is get rid of all these things altogether. And my holy grail here with this effort is to have actually path checker just take the origin and destination and figure out all this horizontal, vertical, diagonal stuff. I don't want board to worry about any of that. But I have a little work to do because we have this is blocked that's sort of the entry point for all this functionality that we're looking to split out into a separate class. So I'm going to use this same trick again. I'm going to inline these methods and make kind of a big, ugly method here. But I'm not too worried about that because that's an intermediate state. So it's nice to extract things to small methods with readable names and everything. But when you're doing something like this, it might actually help you to see all the logic in line so that you can slice it and dice it, refactor it, and break it up in different ways. So what I'm doing here is now that I've inlined this, I only need the one checker declared in this method, so instead of declaring it in 3 places, and I liked how the tool is smart enough to name it 3 different things. That's kind of fun. So now I can get rid of some of this, and this method flattens a little and gets easier for me to reason about. And basically what I'm saying here is I'm declaring this checker thing, and then I'm asking some questions about the board coordinate, and that's giving me 3 conditions, in which case I'm returning 3 different things. So there's nothing in here that's required from the board class except, once again, this does piece exist at. So what I decided to do here, the real goal is to get this does piece exist at in is blocked onto one single line, just like kind of the same thing we did before. It's another step along this. And if we get that under one single line, we can pull the rest of the is blocked method out into the path checker class that's down below. Or wait, did I? Oh, it looks like at some point I was talking over myself, extracting that to another file. Or to its own file as part of refactoring. So it's not inline anymore. I've got it sussed out well enough, I guess, in my head to pull it out. So here's what I'm going to do. I'm going down here and I am going to declare, just follow the same basic pattern where instead of returning a bool from the things in this condition, I am going to return a collection. And you'll notice the copy and paste I'm doing. Normally, I always kind of advise against that, type it out. The reason I'm not here is because what I really want to do is cut and paste, just move it, but I'm sort of hedging my bets as part of the refactoring. So don't think of that really as a copy and paste. It's more like a move, but I'm sort of doing a Schrodinger's cat kind of thing with it for the time being. So now what I want to say is I'm going to get these spaces to check from my little method down here that I've just written. And then I want to return whether the spaces to check, whether any of them have a piece in them or not. Now I've got this kind of holy grail of doing this all on one line. So at this point, I can go ahead and pop this get spaces to check method into the path checker. So that's what I'm going to do. This time, true to form, or true to my word, as I said, I'm not really looking to copy and paste. I'm actually looking to delete and paste. So I'm going to make this guy public. And I am not in need of these origin and destination. So I'm, again, following the same form, doing the same thing, making this into fields. And then once that's done, I'll go back and factor the original class towards, just as we did before, declaring a checker. And then I figure this should work. Now, there's going to be some interesting to-dos either in the next video that I do or one down the line where we're going to have to do some reasoning about the API of this class. Do we want just the one method that kind of gets all the spaces to check and figures things out on its own? Do we want to have those diagonal, vertical, and horizontal methods exposed? To be determined. It's something to kind of reason about and figure out. And we'll let the tests kind of drive that too. We'll reason about that as we write the tests for it. So now I still have this is blocked functionality, but it's very focused. And I'm going to do a little bit of renaming here. I think that I wasn't thrilled in the end about the spaces to check. So I called this get spaces along the path. Path checker, spaces along the path makes sense. So I declare my checker, I get the spaces along the path from origin to destination, and then I figure out if any of them are blocked based on the state of the board. That, to me, is a pretty reasonable implementation of board. So there is still this concept of is blocked. I need that. That's sort of the property of the board. But all the stuff about figuring out paths is elsewhere. The board just kind of takes pieces, adds them, removes them, moves them, and then has some special considerations about the kind of paths you can get based on whether it's blocked or not, but we're not reasoning about nearly as much of that. So I'm going to move that over, and then I added a couple of cards. I want to start test driving and add coverage around that path checker class and answer some of the new questions that have arisen from dividing up that functionality. So add some tests around the new path checker class. And I don't remember exactly what I wrote since this was a couple of days ago. For non-happy path conditions, in other words, yeah, what if I'm passed essentially a horizontal path and I call get vertical path or something? Got to figure out how to handle that. And then I'm trying to remember the other thing, so I guess you and I will both discover the other thing I put on the board in a second. I just remember that I put a second thing. Still stumped. Look for opportunity to use... yes, I wanted to look for the opportunity to use path checker perhaps in the piece classes like rook and bishop and such. Get maybe as much mileage as I can out of that. So we'll see if I can. Hopefully I can. And that's it for this episode. Tune in again for the next one, and I will, or you will hear from me then. Thank you.